Number 42, an object with mass m and speed v relative to an observer explodes into two pieces, one 3 times as massive as the other. The explosion takes place in deep space. The less massive piece stops relative to the observer. How much kinetic energy is added to the system during the explosion, as measured in the observer's reference frame? Okay, so let's say that this is our observer. And initially the object, let's say it's like a ball, is traveling to the right with speed v, and the mass of the object is m. So the object explodes, and then we have a small piece that stops in respect with the observer. So let's call it v2. It will be 0, and its mass it's 1/3 of the mass of the other object. So the mass of this object here is m/4, and the rest of the object is 3m/4. So now you can see that the mass of this piece is 3 times the mass of this one, right? Okay, and the speed of this piece over here we don't know, so let's call it v3 for no reason. Okay, so that's the information that we have. We want to calculate the increase in the kinetic energy. Let's remember that the kinetic energy is equal to mv²/2. So using our notation, this is the initial kinetic energy. So the initial kinetic energy is mv²/2, and the final kinetic energy is equal to 3m/4 times v3²/2. So we just have to make the difference, the final kinetic energy minus the initial kinetic energy, and then we know the increase in the kinetic energy. Okay, so the thing that we have to calculate now, so we have m is m, v is v. The only thing that we don't have is v3, so we have to use conservation of linear momentum to find v3. So initially we have the initial linear momentum, and the final linear momentum must be equal to the initial one because we don't have any external forces, so the linear momentum it's the same. So initially linear momentum is just m times v, and after the explosion the linear momentum is 3/4 m times v3. So v3, we can cross m out, is going to be equal to 4/3 of v. Okay, so now we can solve this equation over here. Remember that we want to calculate the change in the kinetic energy, which is equal to the final kinetic energy minus the initial kinetic energy, and this is going to be 3/4m times v3, which is this value here. So 4/3v squared times 1/2 minus mv²/2. So we can simplify this. So this is going to be let's see, this is going to be 4/3 mv²/2 minus mv²/2. So if we sum this, we are going to get, let's find the minimum common multiplication value over here. So this is going to be 8/6. We don't need that actually. So let me see, I have to multiply this by 3 over here. Okay, now it's easy to do the calculation. So it's 1/3 mv² times 1/2. So this is equal to mv²/6. So this is the answer because we don't have the numerical values, but we know that M is M and V is V. So that's the answer of this problem.